everybody. Today we're going to talk about titrations and how it can be used to find the concentration of an acid or a base. First of all, what the heck is a titration? Fill that in. It's a carefully neutralized or controlled neutralization reaction. So we've talked about neutralization reactions already. Now we're going to control it carefully and try and get it to the point that it is exactly neutral. So what you're going to need to do this, and you want to make sure that you write these things down, because when you do the lab, you're going to need to know what goes where. So first of all, you're going to have an unknown. So what is meant by the unknown is you don't know the concentration. I'm going to tell you what the substance is, like it's sodium hydroxide or hydrochloric acid. What is not known is the concentration. And you're also going to need a strong solution, and I'm going to tell you that concentration is going to be 1 molar of the opposite. So if you have a base, you're going to have a strong solution of acid to titrate it with. As you can see here, if I have a base, unknown base, you'll titrate it with the strong acid. And that'll be 1.00 molar in the lab that we do. You're also going to need a burette, which will deliver the known solution, and you will see a demo of that here in a little bit. And you're going to put an indicator into the flask with your unknown concentration solution to tell you when you are done. So how do you know when it's done? Well, there's two points here to know. The equivalence point is where neutralization occurs. In other words, where the pH is exactly 7. And you could use a pH meter or something like that, but that's a little tricky, and we don't have a ton of those. So we're going to use an indicator instead. And when that changes color, that's called the endpoint. And we're going to use an indicator that changes right at 7 here. This bromothymol blue is a great pick because it changes right at 7. If it's exactly 7 as a pH or has a color of green, we're going to see yellow or blue, and if it changes in 1 drop, that'll be just fine. But if you get that green color, that'd be great. So once it's done, then what do you do, or why do we care? Well, we can get the concentration. So a lot of different ways to find concentration of chemistry, and a lot of reasons why we want to have concentration in chemistry. For instance, we want to know the concentration of a certain drug in blood, or we want to know a certain concentration of an ion in drinking water. In this case, we're going to find the concentration of an acid or a base. In the case of those of you that went to St. Cloud State, you found a concentration of dyes in some household goods. So those are all different ways of finding different ways of finding concentration. This is just another method that scientists use. So what, as far as what you do with that information? So at the neutralization, the following is true. The moles of hydrogen ions from the acid is equal to the moles of the OH minus ions from the base. We're going to be able to use an equation from the past, M1V1 equals M2V2, because the total moles of the hydrogen is just equal to the volume times molarity, that is moles, and the total moles of hydroxide is volume times molarity. You're going to have 3 of the 4 variables, and you can solve for the molarity of the one you're looking for, or the unknown. And at this point, you can put in hip, hip, or hip, hop, hooray. Either one is just fine. So how can we do a problem? So these notes will help you with your lab tomorrow as far as how you're going to set it up. The practice problems we're doing now is going to show you how you're going to solve it. Not only how you're going to set it up, the notes will help you also figure out how you're going to get your data. But then once you have your data, how do you solve for that concentration? So we're going to use M1V1 equals M2V2, and I'll show you how that would work. So in this situation, M1V1 equals M2V2. I always just have the acid on the left, the base on the right. Really doesn't matter, but the acid is going to have a hydrogen in front. So I'm going to put 0.100 molar times 32 milliliters. Doesn't matter if you have it in milliliters or liters. Just so you know, if one's milliliters on one side, the other one's milliliters on the other side. And then if I want to know the molarity of the NaOH, that's going to be times the 43.0 milliliters. If I do my algebra correctly and solve for M2, in this case, I'm going to go 0.0744 molar, which should make sense that it's a smaller molarity than the acid because I need more milliliters of it than I do of the acid. So the moles in the end of acid and base are equal because of that. So that would give us the molarity. But the reason why we can just use a regular M1V1 because M2V2 is because there's 1 hydrogen and 1 OH. But when this neutralization occurs, if there's more than one, you have to take that into account. So in this situation, we have the acid, which is HClO4. So there's one hydrogen there. And the base is a hydroxide, but there's 3 hydroxides. So what that means is that when this splits apart, it's actually going to make 3 times as much hydroxide than aluminum. So we need to take that into account. And we could do that with some stoichiometry, but I'm just going to show you how I would typically do it. So here we don't know the concentration of the acid. We do know the volume is 35.0 milliliters. The concentration here is 0.70 molar times 9 milliliters. And at this point, before I do the algebra, I'd also multiply it by 3, because there's 3 OH minus ions donated for every 1 aluminum hydroxide. Really, it's like this molarity is a 2.1, which we could change that to 2.1 instead if you wanted to, but depending on what you're solving for, it's a little tricky. So when you do this math and solve for the M1, you should get 0.54 molar. But you need to take into account the fact that when this goes through a neutralization reaction, it's going to donate 3 of the hydroxide. So it's really like it's a 2.1 molar of the hydroxide ions. That's what it would be like. So I multiply by 3 before I do the algebra. One more problem like that, or similar to that, but with some different values in here. The acid here, the one that starts with the hydrogen, is H2SO4. So notice how there's 2 hydrogens now. The base is NaOH. You won't need to worry about this in the lab, because in the lab it's HCl and NaOH, but you will see something like this on the test. So on this one I would put 0.120 molar times 25.0 milliliters equals M2, which I don't know, times 40.0 milliliters. But I'm going to multiply this side by 2, because really it's going to be like at 0.24, because when it goes through this reaction, it's going to break apart 2 of those hydrogens. So in this case, if I solve for M2, it would be 0.15 molar. If I multiply 2 times 0.12 times 25 and divide it by 40, I should get 0.15 molar in that situation. So you have some practice problems that you are going to do that are just like this, and you'll be performing a lab as you'll see in a demo following this examples.